Hi there. In the last video, we looked at sampling the normal distribution and said that if we were getting ready to take a final exam and we had some expectation of what we thought we'd make, and our uncertainty was normally distributed, and we had some idea of the width of that distribution, the standard deviation, and we could assume a probability, then we could calculate the actual grade for that probability that we might get using the norm dot I think we call this the inverse normal function in Excel. I call it norm.inv. Probability, comma, mean, comma, standard deviation. And so notice every time I recalculate a new random number here for probability by hitting F9, then my score changes. And so if I did that many times, I would get a distribution of scores. So let me copy those things up to project. And let's build a little Monte Carlo simulation here that says we expect an 85, let's say we expect a 90 with a standard deviation of 3. And on the final, we expect an 85 with a standard deviation of 5. Now these are our random numbers. I've got a model here where these are the inputs, but now that they're based on the probabilities, I'm going to go ahead to follow the rules and make these the inputs. And copy that, do an Alt-H-V-S-T. And then we can come over here and build a Monte Carlo simulation where we have iterations. And remember, this is data table on a blank cell. The blank cell is going to be yellow. And then we'll count our iterations. We're going to do more here in a moment, but right now I'm just going to do 25 because I'll stay on the screen. And the output that I want is the course grade. I'm going to get some intermediate outputs though. I'm going to pick up random number that's driving the project in that iteration, the random number that's driving the final in that iteration. I want to get the project. In fact, I'm going to, project grade. And final exam grade and course grade. Now I'm going to cut and do a Control-Shift+ to flip-flop those two so that my random number that's driving the project grade is right before the project grade itself. So I'm going to say equal this tab, equal this tab, equal this tab, equal this tab, equal this. And now I have those outputs, Alt-H-J output. And so let's build this data table, Monte Carlo simulation. And what it's going to do is 25 times it's going to select a couple of random numbers to drive these two grades and calculate a course grade. Alt-A, W-T, tab. And we want to select the yellow cell. And what this data table did is it ran 25 equally weighted scenarios. So any of these 25 are just as likely as any other. And each one had a random number that drove a project grade and a random number that drove a final exam grade. And then the course grade that would be calculated from the project grade and the final exam grade. So by putting in two uncertain variables, we were able to calculate a distribution of possible outcomes. And then we could run some statistics on that. We could say, well, what's the average of our course grade from that simulation? What's the P10 or the P90? In other words, do I have a 90% chance of getting a number higher than X or a 10% chance of getting a number lower than X? So for now, let's just go with that, but let's try to make a chart of it. And what I would like to chart is a bar chart that says how often did I get an 85 or an 86 or an 87 up through, well, I think a 95 will be sufficient here. And there are different ways to calculate how many of these numbers fit into each category. I'm going to teach you one called the frequency function. Frequency is a little bit funny because it's an array function, and you actually have to select all the cells that you want the answer in before you type the formula. And the formula is frequency. And what it does, it looks at a data array and it says, I will count up all the numbers in that array that fall into these bins. And so you've probably used statistical packages that create histograms for you. That's what we're going to do here. Now, pay attention. To get this formula to work correctly, since it's an array formula, you have to type Control, Shift, Enter. And if you do, it says, well, there were 5 that were less than an 85. There were 3 that were between an 85 and an 86. And so on, and it gives us that histogram data. So clearly I didn't start low enough. I'm going to replace some of these with like an 82, 83, and copy those down, autofill those down. Wow, in that particular scenario, we're only running 25 iterations. Not a single one of them was an 85. But if I hit F9 and I recalculate, if I rerun the simulation, now 2 of them were 85s, and 86 happened 8 times out of 25. So let's make a chart out of this. Let's first insert the kind of chart we want by going to Alt-N for insert, C1 for chart, and then column. I don't know how Excel found that data. I don't like it when it tries to outsmart me, but it outsmarted me. It actually did a really good job this time. It found the frequency of all these numbers. We'll talk more about charts in a different video. And so if I rerun the simulation, it's a very different looking chart. And that's because we're only giving it 25 iterations. What I'm going to do now is increase this to 1,000 iterations. I'm going to leave these formulas the same. I'm going to delete all of these cells because, as you know, if I tried to insert a row in that table, I'd get an error that said something like, if I tried to shift those cells down, it would say you can't change part of a data table. And I'll say, well, fine, you're not a data table anymore. But I still have formulas that are looking at those ranges. So what I want to do is choose some cells inside those ranges. And when I insert to add 975 rows, it will adjust those formulas. I'll show you in a moment. So I had 25 rows. If I add 975, doing a Control Shift plus, shift the cells down. Now look what it did to the formulas. If I hit F2, so now the data array that it's looking for goes all the way down to row 1000. Well, 1005 probably, 1004. Now I don't know a good way to autofill this down to 1,000, but I do know that I can say equals this plus 1, and I can copy that cell, do a Control Shift down to where we were before, get all the way down with the shift down, and then Control V to paste that formula. And now it's calculating, so it's counting my iterations, but that's a formula, and it's just going to slow Excel down to have to calculate that every time. So what I'm going to do is come up, Control Shift down, Control C, and Alt H, V, S, and instead of T for format, I'm going to say V for value. And so everywhere where it said equals the cell above it plus 1, now it's just going to paste that value in there. And so instead of saying plus 1, if you're looking up here, you're seeing that I just have values. So that's good. Now I can rebuild the data table on a blank cell. I'm doing Alt-A-W-T, Tab, and we will put each of these iterations in this blank cell and rerun our simulation, this time 1,000 times. And notice we get a much smoother distribution when we run 1,000 iterations than we did when we ran 25. So if I hit F9 again to rerun the simulation, notice it changes a little bit, but the shape is more consistent. Now what do we really care about? We care about letter grades. So what is the sum of this over the sum of this? Well, it's my chance of getting an A, right? So this says I have a 14%, let me do an Alt H0, 13.5% chance of getting an A based on these 1,000 equally weighted scenarios of what might happen, iterations. So let me hit F9 again and see if my chance of getting an A is similar. 14 versus 13.5. Let me hit F9 again. 14.8, 15, 14.5. So every time I rerun the simulation, I get 1,000 different possible outcomes, and sometimes they happen to be a little more positive than others. But what I'm seeing here is I've probably got about a 1 in 7 chance of getting an A. And so if I had another class where I had a 1 in 2 chance of getting an A, maybe that would be the place to spend my valuable study time. Let me see if I can get this to be more consistent by running 10,000 iterations instead of 1,000. And let's remember what the range was here. So I'll just type 14.2, 14.9, 14.0. Okay, that's a pretty good representation of how noisy this data is. So I'm going to do the same trick. I'm going to get rid of the data table calculations. This time I am going to insert 9,000 rows. So let me hit F5 to go to J 10,005. So I'm going to select these cells, do a Control Shift up, and then I'm going to do a Control Shift plus. Shift those cells down. And now when I go to these formulas, they're looking all the way down at row 10,008. I don't think I got that quite perfectly, so let's go ahead and do our equals this plus 1, copy it to there, paste it, copy it, do an Alt HVS V for values. Go down, I got 4 extra rows, so I am going to do a Control minus and shift those cells up. Let's rerun this data table. It's probably going to take a long time because it's 10,000 iterations, 10,000 times it'll have to run that model. Alt AWT, tab, yellow cell. Okay, this time it says a 14.6. 14.1, 13.9. So see how much more consistent the outcome was when I had 10,000 iterations instead of 1,000 iterations. Now you have to ask yourself, was it worth all the extra computing time? Because this is a pretty simple little model. If we had a pro forma model to value a company, it would not be this simple, and it would take many, many, many times longer to run. So would that extra computing time be worth this extra accuracy? I don't really think so, because I'm not that comfortable with the numbers going in. You know, whether that's a 6 standard deviation or a 3, I'm not so sure. And so to know that it's about a 1 in 7 is very valuable to me. But to know that it's 14.4 instead of 13.1 or 16.5 is not really that helpful to me. So it looks like it's about time to wrap this video up, and in the next one we'll try to do a financial example.